don't know.
I hope so.
Hopefully.
All right, just tell me whenever you're there.
I'll start it right now so I can see it.
Yeah,
And I actually don't have SPSS on my computer. I go to the library and do it. So
okay.
do you have SPSS on your computer?
Yes, but we don't need SPSS for this one.
Oh no, we don't. I'm
So
looking at it right now.
Yeah.
All right, cool. All right. Oh, it's all probability. Okay, yeah, that's great.
Yep.
Given in the table above, define a probability distribution.
Are you looking at number 3?
Yeah. Sorry, I'm reading
You're
the
good.
table info.
Yeah, tell me when you're ready.
Okay. So that would be true, right?
Yeah, I got true. Because they all add up to 1, so
Yeah.
So I put true.
That works.
Okay, so
Right,
for 4, I'll let you read it. You're good.
What is the probability that a randomly selected person in the United States has a type O blood? Round to the 2 nearest decimals. So they have a 0.45.
Yeah.
That's their probability. Yeah.
Yeah. I think, well, he'll want us to put in like 0.45, right? Hopefully.
Yeah, that's what I put in.
Yeah. Okay. So for the next one,
Yeah.
what is the probability that a randomly selected person will not have type O blood to 2 decimal places? Well, we just subtract that from 1, 0.55. So
yeah. Okay. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round to the answer to 3 decimal places. So if there's 7, it would just be 1 divided by 7, which is
0.143. You can calculate it though if you want to.
Oh, you're fine.
Okay. In a combined, okay, this one I wanted to talk to you about, so give me your thoughts. But in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is the most appropriate? So when you divide that, 22 divided by 54, it's like 0.40. So like that's like a 40% chance. So I mean, it's not like overwhelming, but it's like, okay, it's better than random chance alone. But anyway, so I put this provides strong evidence that dogs can detect bladder cancer, but I don't really know like what it means by strong. Like it's not necessarily reliable, you know?
Yeah, I'm thinking it's strong evidence too, because it even says like it is very unlikely that the dog would do this by random chance alone. So like it even says that in the question.
So that's what I was thinking.
Strong evidence.
Because it's not like definitive. It's not like, you know, you get like a test done and then it shows cancer cells, but it's like more anyway. So I put strong.
Is there like okay, cool. That works for me.
Okay.
So M&Ms are small candies. The M&M's website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? 0.13.
Yeah. What is the probability that a randomly selected candy is green? So you add them all up and you divide by 1 subtract from 1, and then that would be 0.16. So that's for the green M&Ms.
0.16. Yeah.
Go ahead.
So what is the probability that a randomly selected candy is not green? So 0. 0.84.
Yeah. So then we'd add those together. They add to 1. So yay. ACT scores of students admitted to a medium-sized public university in the Western United States were taken from capex.com. The following summary statistics were calculated. Half of the observations are less than or equal to what number? So that would be the median. So that would be 24.
Right, based on the information of the table above, the top 25% of the students scored above what number? So that would be the median of the top half. So would that be like in between? Sorry, let me count. Are we counting 24 with it?
Well, I put 27 because Q3 is the 75th percentile. And so if it were the top 25%, then that would be Q3 to the maximum. So it would be like 27, like above 27.
Yeah. Okay. So, which of the following statements is not of the 3 rules probability? If the probability is high, then the probability is positive. Okay. I'd have to look that up because they're all true, right?
Well, do you remember?
Except for the first one.
Yeah.
I guess it's not going to be negative. I was thinking that would be low, but okay, cool.
Yeah, just they all add up to 1, and then 1 minus the other, like we did with the green M&Ms.
Yeah,
and then it has to be
between 0 and 1.
Yeah.
Okay, cool.
Alrighty.
Okay.
How was your week?
It was great. Yeah, it was great. Last night was like really rough, but it's just because like I went to the Brandon Flowers concert in Salt Lake City last night.
Oh, cool.
So I like drove there and back, and it kind of sucked.
And now you're like kind of sick.
Yeah. Yeah, well, I was a little sick before, but like I bought the ticket like a few months ago, so I'm like, Well,
that's super
great. How was yours?
Pretty good. Like I had work yesterday and today, so stayed up and got my statistics stuff done last night, and then coming home for work. So, yeah. Yeah. Gotta make it work around. All right. Are you good like with this week's material?
Yeah, I'm good. Are you?
Yeah. Did you want to go over any of the homework stuff?
No, I was fine. I did it like I don't know. I did it like Friday, so I don't think I had any questions.
Yeah, it was pretty simple. It's just like remembering just how to calculate the, what was it? Like the median, what was it? What's that called? Like, you know how we had to do like the variance and then take the square root of that? Anyway, that was just a little more extensive, so I had to like look back to remember the pattern. But oh yeah, the discrete random variable. But it was pretty good.
Okay, yeah.
Yeah.
All right, cool. All
right, sounds good. All right.
Yeah, and I'll text you about the time on Thursday. Yeah. So I'm not sure if we have another game, but if it's usually done at like this time around. So.
Okay. All right. Yeah, and I work Thursday, so.
Oh, you do? Okay.
So, but it'll be like the same as today. I get off at like 6, so I'll be good.
Okay.
Yep. All right. Well, good night.
All right.
See you later.
Yeah, good night.
Bye.
Yeah, bye.